Electron Configuration, Molar Mass, and Ionic Compounds by Tristan Todd. Number 1. Electron Configuration. Number 1. Principles of configuration. Electron configuration is the distribution of electrons in different energy levels and follows four main principles. The first states that electrons are arranged in energy levels, which are identified by numbers, and within each energy level, electrons occupy atomic orbitals, which are identified by the letters S, P, D, and F, in that order. The second principle, the Aufbau principle, states that the lower energy levels, 1, S, and so on, must be filled with electrons before the higher energy levels, the ones further away from the nucleus. The third principle, the Pauli exclusion principle, states that two electrons in an orbital must have an opposite spin. The fourth, Hund's rule, states that all orbitals in an energy level should have at least one electron in them before doubling up on one orbital. Number 2. How to write it. The way to write the electron configuration of an atom is to begin listing the energy levels according to the periodic table. The numbers from left to right, while the letters are in blocks, where S is all of group 1 and 2, D is groups 3 through 12, and P is 13 through 18. For example, hydrogen is 1s1, 1 representing the row, S representing the column, and 1 representing the number in that column, left or right as well. When listing an element, all other sublevels must be written as well. For example, when writing something like oxygen, you must first list 1s1, then 2s2, then 3s2, as it goes left to right, and finally 3p4. Alternatively, an abbreviated version is possible by listing the nearest noble gas and then simply listing every energy level following that noble gas. For example, a higher energy element, like calcium, can be written as Ar, the closest noble gas above it, 4s2. Number 2. Molar mass. Number 1. Basic principles of molar mass. To start off, a mole is a unit of measurement used for atoms. A mole is equal to 1 atomic mass unit and is written as G/mol, grams per mole. The usefulness of moles comes from the fact that it can be used to convert a given amount of an element into another unit. The way to find the molar mass of a compound is to add up all of the molar masses of the individual elements and add them together. To convert an element into moles, divide the given weight, if in grams, by its molar mass. For instance, 15 grams of lithium divided by 6.94, its molar mass, which equals 2.1 moles. For an amount of an element in liters, you must divide the amount by 22.4, and it will be moles per liter. For moles to grams and liters, the known numbers, molar mass, or 22.4, must be multiplied, not divided. Number 2. Formulas. Formulas include percentage composition, the empirical formula, molecular formulas, and hydrates. To start, percentage composition is simply the percentage of a compound an element makes up. To use this, simply divide the molar mass of the desired element by the mass of the entire compound. Moving on, empirical formula is the lowest whole number ratio of a compound. In other words, the percentage divided by the molar mass, and then all quotients divided by the smallest quotient found of those numbers. After empirical is the molecular formula. The molecular formula is used to find the coefficient in front of a compound by dividing the molecular mass of a compound by its molar mass, then rounding that number. And finally, the composition of hydrates. Hydrates are compounds bonded with water molecules. The composition of hydrates is broken down into the compound and the water, and the formula is used to find the percent composition of both. And just like the percent composition, you take the molar mass of the water and divide it by the molar mass of the compound. Ionic compounds. Basics of ionic compounds. Ions are formed when an atom loses or gains electrons. Gaining a charge, an electron, forms an anion, and losing a charge forms a cation. Cations are named like normal elements, followed by the word ion. Anions are named by adding an "ide" at the end of the element, followed by the word ion. Ionic compounds are formed when a cation and anion combine to form a neutral charge. Ionic compounds must be neutral. To balance an ionic compound, sometimes the number of each element must be changed. For example, Na plus and O2 minus becomes Na2O instead of NaO to balance the charges correctly. Likely charges and transition metals. Likely charges are the most likely charges the main groups 1, 2, 13 through 17 elements would have to become to be stable. As you know, 8 valence electrons make an atom stable. However, all groups aside from noble gases have less than 8. When they ionize, however, the amount of electrons in the outermost shell can change. Groups 15, 16, and 17 are very likely to gain electrons, as that would help them reach stability. However, the other groups would benefit from losing electrons, as if all valence electrons are gone. The next level becomes the outermost shell, and because that level already had 8 electrons, now turned valence electrons, the atom is stable. Group 14 could either lose or gain electrons, as it would be a charge of 4 either way. As for groups 4 through 12, the transition metals, the charges vary depending on the compound at hand. In other words, transition metals have multiple charges. For example, in Fe and O has a charge of -2, as it has 6 valence electrons and wants to gain 2 more. For the ion to have a total charge of 0, Fe must have a charge of +2. To name these ionic compounds with transition metals, simply include the element and in parentheses right after the charge written as a Roman numeral. Thank you for listening.